In this module, we will talk about the ways growers can minimize the impacts of insects, weeds, pathogens, and microorganisms damaging to human health, as well as new equipment we can use to apply solutions to the field. Our next speaker, Dr. John Palumbo, is an extension and research entomologist in the Department of Entomology at the University of Arizona, Yuma Agricultural Center. His primary role at the university has been to develop a translational research program to investigate the biology, ecology, and management of important pests associated with Arizona vegetable production. Today, he's going to speak to us about soil-applied insecticides and their role in desert agricultural production.
I'd like to just give you a real brief overview of soil-applied insecticides that the growers and PCAs use in the southwestern desert on their desert veggies and melon crops. Here's the answer. Here's an answer for you. When I first started down here in Yuma in 1990, the only soil systemic insecticide available for the industry was Dicyston, both the 15G and the liquid formulations. And they, by the time I got here, they weren't very effective. Aphids, which were the primary target, were pretty much resistant to OPs by that point. And growers didn't like using the product. It was extremely toxic. It was one of the more toxic OPs around. So I know I messed around with it a little bit, but I really didn't care to work with it. That all changed though in 1993 when the Arizona growers requested a Section 18 for imidacloprid, Admire 2F for vegetables and melons in response to the whitefly crisis that we had going on for the previous 2 or 3 years. Essentially a single at-plant application provided 45 to 60 days of protection against sucking insects and predominantly against whiteflies at the time. It was brought in specifically for that. To give you an example of how important it really was, this graphic kind of just shows you some trials we were doing with growers with embedding untreated checks in their Admire treated fields. And in '93, you could see an immediate response from the Admire, and the area wide, the numbers were still quite large. By '94, growers started to figure out how to use the material a little better, timing, placement, etc. And you can see by '94, '95, there was widespread adoption of the product. Everybody was using it, 100% of the acres. And then certainly by about 1996, we started to see what I consider area-wide suppression. And it's pretty much been that way with a couple of hot spots now and then, from now and then. What's really interesting is that after all this time, imidacloprid or Admire or one of the generics is still the #1 product used in leafy vegetables, head lettuce and the other lettuce varieties, both for whiteflies and aphids. At planting applications, there are other alternatives that are used, but particularly since the product is so inexpensive now, a grower can put it out from anywhere from $10 to $15 an acre, and it still provides expected results. Since that time, there have been a couple of other neonicotinoids, this classic chemistry, other products that have come out of that. Since imidacloprid, we've actually seen new formulations of imidacloprid, both generic and branded. Thiamethoxam, platinum came out shortly thereafter. Very, very similar, a little more water soluble than imidacloprid. That was followed by clothianidin and dinotefuran. Dinotefuran, better known as Venom, very water soluble and has a really good fit in our melon crops, whereas clothianidin has got a fit as a seed treatment. And I'll talk a little bit about these time permitting as we go along. Shortly thereafter, about 2010, a new class of chemistry came out, the anthranilic diamides, beginning first with Coragen. Both of these products had both foliar and soil activity, And in the case of coragen, it would control Lepidopterus larvae. And that was the first time we'd ever seen a product that could be applied to the soil that had lep activity. This was followed a few years later with Verimark, same class of chemistry, different product, but it had activity not only against Lepidopterus larvae, but against sucking insects and predominantly whiteflies. So we kind of got lucky. Industry really came up with some real winners following the Neonics. And then most recently, we've seen the registration of Savanto. Again, soil systemic and foliar activity, but as a soil systemic, it really provides really good activity against whiteflies on melons and even aphids on some of the other leafy crops. So that kind of gives you an overview of what products that are presently out there, current time, that have soil activity. Now, the one thing that all of these products have in common is that they have xylem systemicity. They are active when applied to the soil, to the root zone, and that plant starts to germinate. It actually picks that material up, moving acropedally up the plant through the xylem, and actually provides protection. And that was real critical, particularly in the whitefly days, when melons or small lettuce plants, small broccoli plants would germinate and emerge out of the soil. They'd be covered with adult whiteflies. And now with these soil insecticides, they're protected pretty much for anywhere from 30 to 60 days, depending on the product. So now I'm gonna, that was a pretty brief overview of these products. Some of the things that make these products differ from each other are obviously some have better activity against one pest as opposed to another pest. They have different spectrums for sure, particularly when you consider the anthranilic diamides. They have different soil properties in terms of their mobility in the soil, their movement with water, their binding, their ability to bind to the soil. And for the most part, most of them bind pretty tightly to the soil, to where they're being placed or where they've been applied. There are exceptions. Thiamethoxam's a little more soluble, a little more mobile, if you will. And then you've got dinotefuran or venom, which is very, very mobile. It's like nitrogen fertilizer. It moves wherever you push it with water. So just to give you some little additional information on these, because that's probably the one most important principle of these products that comes into play when we tried to start developing methods of actually applying them to the soil. And so that's what I want to talk about now. And I'll give you some examples of products and maybe some efficacy data a little bit. Some of the common methods, and there are 4 primary methods. And I'll start first with the soil shank injections. Again, I mentioned that a lot of these products, and when we first started working with soil products, we were working with the metocloprid, and it was not mobile at all on the soil. It's got a water solubility of about 521 parts per million, so it doesn't move a lot, but more importantly, it binds to organic matter and it binds to heavy clay soil. So essentially where you place it is where it's going to stay, and you can push it and push and push it with water, and it really isn't going to move more than maybe an inch at the most. So what we determined right off the bat was that when you shank something into the soil, you've got to be able to place it where it's going to stay in an aqueous solution in that root zone, particularly as the plant's germinating and starting to actively grow, because that's when you want the protection, and that's when you can really mobilize that insecticide. So placement's real important with all of these soil treatments, and especially most of the nicotinoids and the diamides. So talking about shank injection, when we first started to use Admire Pro back in the day, and then even more so, most growers, and I think even us when we were doing our research, we were applying it with the bed shaping operation. Anywhere from 7 to 10 days before planting, growers will go in, list the beds, and then they'll follow it up with these bed shapers. Well, guys were mounting these fertilizer shanks on the front end, and from there, that's where they were placing it. They would adjust them for depth and place the Admire precisely, estimating where the seed line and at depths where it was going to be. And that worked pretty good. Problem with that is, though, is that at least here in the Yuma area, a lot of growers will shape their beds anywhere from 7 to 10 days before they actually plant, and so the material sits out there for that same period of time in the hot, dry soil. And what we found eventually is that you lose those days on the back end in terms of residual control, because it just sits there and it starts to break down a little bit, particularly if you get a monsoon storm to sort of activate it. So that was initially how we did it. I think most growers today, and I know we do here on the Ag Center when we do our trials, we're actually applying it, shanking it in at planting, where the shanks are placed right in front of the boot, the planter boot, and that way you have a lot more control when you're pushing dirt over a shaped bed of where that material is actually going to be. And again, I mentioned placement is really, really important. Here's some work we did real early. This is from 1994, where we were looking at different placements. The one I didn't put in here, we were actually banding it on the soil as well. But I think if you just look at this real simple graph, that residual control was achieved, the best residual control was achieved at a depth of about 1.5 inches. You can see the deeper you went, the less residual you would see, less residual control. The banded application initially provided really good control, but because the soil dries up so much on the top of the bed, you really couldn't maximize or optimize the placement. So bottom line was we found that 1.5 inches was about right. And if you look at the root system relative to the placement, it kind of makes sense. At 4 days, that little seedling is sticking the primary root down, and it intercepts the zone of placement and picks up a little bit. And then as those feeder roots, like you can see in days 21 days out, or about thinning stage, those feeder roots really are the ones that are doing the major work, pulling the product in. And then even at 40 days, if you've placed it properly, you're probably still pulling a lot of material into that plant. So again, just to emphasize, and we did this for years, placement's important. For our produce crops down here, it's our recommendation is to place it directly below the seed line, because that's where you're going to get the maximum pickup from roots. Because remember, roots grow symmetrically, not just like this little two-dimensional image shows outward. They grow down the seed line as well at about 1.5 inches to 2 inches. And that seems to be the optimal placement to get your maximum effect from the insecticide. And that's been something we've known for a long time. And that was with Admire, and all of these other products are pretty much the same way, with the exception of Venom, because it's much more water soluble. You have to be real careful where you place it, and it's not used in our produce crops a lot because of that. We use so much water for germination that you'll actually move that venom right out of the root zone. There is some side dressing. It's predominantly in our melon crops. We found that the admires, the diamides don't do well as a side dress because they don't move. You can't push them to the roots, so the roots have to find the material, and you only get a fraction of the roots that can find it that are actually growing out towards the shoulder of the bed, as opposed to something like Venom, which is very soluble. It works really good in melons because you can shank it on the side of the bed, shoulders of the bed, and you can push it to the roots, much like you would nitrogen fertilizer. And most growers do combine their fertilizer with their Venom application. And that works really well. But that's about the only situation as a soil shank where we can get an effective side dress application. Just to show you some examples. This is a Verimark trial we did a couple years ago. You see the major difference between the size and the color of those plants. That's a function of whitefly control. Verimark basically did a great job of controlling the whiteflies. The untreated, heavily infested, you can see the white stalk. That's a function of whitefly feeding. And ultimately, the broccoli crown will turn white, at least the stem will, and that reduces its quality. So you can see, give you an example. This is about 35 days after emergence. Here's some data to kind of illustrate. This is a 5-year study, replicated, conducted exactly the same every year. I think what it illustrates more than anything is that Verimark is a very effective whitefly material, as is Admire still. Admire at the top of the rate, Admire Pro here. very comparable, probably not quite as consistent as Verimark, but again, both products perform very, very well against whiteflies using a shank injection. You'll note the other neonics don't do quite as well for a variety of reasons. Let me shift real quickly over to drip chemigation. It's essentially a shank injection, but you've still got the same issues with it's not going to move much away from the drip tape. Some of these products like Admire, the diamide, Savanto, they're not going to move a long distance from the tape itself. A lot of research to validate that. And so placement's not as important because really it comes down to the placement of your tape. Where are you putting your tape? Are you putting it on the surface? Are you, most of the melons that are grown in Yuma and in central Arizona are moving or have moved to drip, and it's all subsurface for the most part. But we've done enough work in the past where we don't really see a lot of difference between surface drip and subsurface. So again, you're delivering wherever the roots are getting it. Timing's important with chemigation, because some of these products that don't move a lot, you want to start that injection at the very front of the chemigation cycle and run it for, if it's part of an irrigation cycle, you want to run it for a long time because you want to try to push it away from the tape, as opposed to something like venom, which is one of our standards in melons. You want to run that, you want to inject that towards the tail end of the irrigation cycle because it is so soluble. You don't want to push it way out of the way where it's going to dry out quicker and the roots are going to not really find it. So again, timing is more important than placement because again, your placement's wherever you put your tape. That's kind of the nuts and bolts of drip chemigation. Again, same principles involved with the same compounds. We've done a fair number of trials over the years, looking specifically at on melons, which is where we see most of our drip used. Comparing drip with shank, some embedded within the same trial, some separate, and we've seen some pretty interesting results. I want to show you a couple of data sets that kind of illustrate some of the information I just gave you. This was a trial, and well, actually this actual graphic just summarizes the average of 3 trials that we ran, comparing drip chemigation to shank, same rates, but these different treatments. And if you look at every single one of those treatments, what you'll see is that there's no difference, no significant difference between the percent of suppression of a virus, cranivirus, or CYSDV. You'll notice, though, that Savanto and venom were by far the top performers. Savanto at a lower rate, not so much. And then Verimark doesn't perform well in melons for whatever reason. I'll further illustrate that with this graphic. This is just drip chemigation trials over 3 years in fall melons. And you'll see the same response in terms of adult control, that being the upper graph, or the virus suppression, that being the lower graph, that the venom and Savanto do a really, really good job when it comes to suppressing that virus and control as a function of controlling adults. Admire and Verimark, not so much. As a matter of fact, not at all, not significantly anyway. And we're not quite sure why that is, because Verimark and Admire work so well in broccoli, which suggests to me it probably has something to do with the root system, a fibrous broccoli root system as opposed to that gangly looking root system that melons have. So for whatever reason, venom works well, as does Savanto, but not the others. So I thought that was pretty interesting. And to this day, venom and Savanto are the standards that the industry uses, particularly in fall melon production, for the protection of those crops from this cranivirus. Let me shift gears real quick. That was chemigation in a nutshell, if you will. Transplant drenches. My first experience with transplant drenches were back, 20 years ago in Zacapa, Guatemala, when I went down there to visit some melon growers who were having some issues. And what they did is they actually drenched their transplants. They would grow all of their whole plantings in these plastic houses for 14 days and then transplant them directly into the fields. But they would treat them with the imidacloprid and thimethoxam by drenching them. And they literally took individual trays and dipped them into 55-gallon cans that were cut in half sideways and just drenched them and let those plants absorb the material. Again, not the most precise application method, and I think that's part of the reason why they were having issues down there. I don't think their application, but that was, when I heard of drenching, that was kind of what I envisioned. And then when Verimark came out in response to, that was a great product. It also has good cabbage maggot activity. And when it came out in 2014, 2015, the growers on the coast were using transplant drenches of cauliflower and cabbage transplants for cabbage maggot control and getting excellent activity. And so when we started to do it here, particularly in response to diamondback moth, I didn't know what that meant. Well, essentially, a transplant drench, as is used by the industry here now, is really no more than just a foliar application in a nursery with their irrigation and or spray boom that goes across the flats, a single pass with the rate that's equivalent to what that transplant rate would be in the field. And then they come back with the second pass with just straight water, with just enough water to push the material into the plug without pushing it out of the bottom of the plug. It's a trick, and there you do see variability in plugs coming out of different nurseries. But the bottom line is that by doing this, you get a much safer, actually more precise method of applying the drench to the individual plants and pots. And then once it hits the field, that plant's protected. You know, once you start the sprinklers and you start to activate that root system, those plants are already, you know, sucking that Verimark into the growing points and into the leaf tissue. So it's been real effective for us for above ground insects and on the coast for maggots that are actually below the ground. And it's great on whitefly. Here's just a test where we compared Verimark and Admire Pro plus Coragen at two different placements when we shanked it, you know, the typical shanking in of these products, 1.5 and 3 inches below the seed line, wherever the plug is going to be put, versus the tray drench. And I think it's pretty clear that the Verimark tray drench was superior in terms of whitefly control and good residual control. The others weren't bad, but they just didn't provide the same level of control. We also noticed when we had our diamondback moth outbreaks in 2016, that it was very effective against the resistant populations we were working with down here. We actually put these plots in March of 2017 when there were diamondback everywhere. We drenched these plots, stuck them in the ground. This is a visual of 35 days after planting. And you can see a clear-cut difference in just the impact of the larvae, diamondback larvae feeding on the plants, and then the protection that the Verimark provided. So this whole concept of transplant drenches is a really, really nice way to apply the product. But again, you're at the mercy of the nurseryman. You know, he's the one that's putting it out, and you pretty much are at his mercy that he's doing it correctly. And you've got to really be very attentive at about 30, because for worm control, you get about 30 to 35 days control, and you got to wait for it to break. If you got heavy worm pressure, you'll see it immediately, but you can't just walk away from it. You really have to stay on top of it and evaluate it to find it when that population breaks, and you'll have to come back and retreat over the top. We also, you know, there's a fair number of growers up in central Arizona and even down here in Yuma that are starting to play around with melon cantaloupe transplants and some of the melon varieties. And so we did some work last couple of years looking at the same concept, because it made sense for the same reason. Once you place that plug in the field, you know, whiteflies are going to jump all over it. And so it'd be nice to have it protected. And again, knowing that our two products, Venom and Savanto, you know, those are the ones that we were most interested in. Well, unfortunately, Savanto is very toxic, phytotoxic to cantaloupes when you're putting a concentrated spray band over the top to drench that plant. If you look at the label, it's got foliar uses, and if you look at it doesn't even have a foliar label on cantaloupes because of the phyto. I was hoping we'd get away with it, but we weren't. Here's another shot of Savanto treated cantaloupes, and again, they just can't tolerate, whether it's the formulation or the active ingredient, I'm not sure, I just can't tolerate it. What's funny about that is, though, you can drench watermelons, you can spray watermelons, you can spray just about any other crop, and you won't see this phytotoxic effect. It's only on cucumin species. It's the cantaloupes. Never tried cucumbers, but I would imagine they're probably the same. Here's just the end result. Once we went ahead and transplanted those plants, and you can see they didn't fare well. As a matter of fact, we basically walked away from those plots because they were set way behind those that did survive. So again, we're now essentially PCAs and growers are left, if they're going to drench transplants, with essentially just venom. We've tried the other products, the other neonics and the diamides, and they just don't seem to work. They don't cause phyto, they just don't seem to provide the level of virus protection that venom provides. So finally, let me just end up real quickly with neonicotinoid seed treatments. You know, this technology's been around for quite a while. They've been using it on corn and soybeans and canola and a number of crops in the Midwest for years. Some with success. You know, there's been a lot of issues with bees, etc. But it's only been recently that I think the vegetable industry started to take this concept seriously. And most recently, they really came up with what I think was a really good product. And that was clothianidin, the one neonicotinoid that we talked about earlier, and treating it with broccoli and lettuce. And they call that product Nipsit. And I started to look at it in response to the Bagrata bug issues that we were having back in 2014 and 15 and 16. And what we found right away is that it worked remarkably well against Bagrata bug. It provided anywhere from 14 to 21 days of control. And it almost gets you to the point where if there were still Bagrata bug around, you wouldn't have to spray. It also has excellent activity against flea beetle, which are, again, seedling pests. Both of these pests are most damaging to the crop when brassicas in particular are at the cotyledon stage, or even younger, you know, right when they're emerging in cotyledon, the first true leaf. And these products, this particular Nipsit product works really, really well. I've been real impressed with it. And there are several growers. Our most recent survey showed about 30% of the growers are using Nipsit. At one point, I think about 50 were, but that's actually come down a little bit. This is just another image of one of the test plots back in 2014, 35 days out after emergence. Pretty clear cut the impact that A, Bagrata has on the plant, and then B, the protection that Nipsit seed treatment provides. This is actually what you're seeing there is as a combination of both flea beetle and Bagrata bug, but nonetheless, you can see that it really provides excellent activity when you have heavy pressure of either. And again, there's been no foliar spraying over any of these plots. So really, just to sum up, to finish up, to conclude this brief overview, you know, these soil insecticides have really been a boon to our desert ag economy. They've really provided key efficacy against a number of important pests. You know, with Bagrata, even with whitefly, flea beetles, they prevent damage to a lot of those stands. And you can just see it in trials, you can see it in commercial fields. It's just the improved stand uniformity, as opposed to having to come over the top and catching up and spraying over them. And with that, you know, if depending on the pressure, a PCA or grower can potentially eliminate 1 to 3 foliar sprays from the program. And then the one thing that I don't think we talk enough about is that it's really been a benefit for both the industry in terms of reducing worker exposure to pesticides, to all our foliar sprays, and then the environmental drift and those type of impact on secondary and natural enemies. I mean, there's not a day go by that there's not there's not a hoe crew, an irrigation crew, a tractor crew, somebody walking in a produce field for the first 30 days of the season. And having those soil insecticides really reduces the pesticide load on that group. So with that, I'm done, Robert.